Let's consider another example of coterminal angle. So example is find a positive angle less than 360 degrees or 2 pi that is coterminal to the following. And I have two options given. My first part is A, which is given as negative 130 degrees. So now let's use an approach with a graph. So this is my x-axis and this is my y-axis. Y dash. Now I want to graph this angle, which is what? 130 degrees. So if you look closely, the sign that I have in front of 130 degree is negative sign. So this is my standard position. This is my standard position. And what I need to do, in order to get a negative angle, I need to go clockwise direction from the standard position. Right? So let's graph this angle clockwise direction. So if I go 1/4, that is 90 degrees. And I need to go 130 degrees. So 90 plus 40 is 130. So this would be my angle, which is what? Negative 130 degrees. So my negative 130 degrees is this angle right here. Right? But look at the question. We are not looking for the negative angle. We are looking for what? Positive angle. So how do I get a positive angle? We all know that if we want a positive angle, we need to go counterclockwise direction. So what we can do, if I want to get this angle, or if I want to keep my initial side, this is my initial side, and my terminal side, this is my terminal side. If I want to keep my initial side and terminal side same for two given angles so that they can be coterminal angles, I need to go counterclockwise direction all the way to that side, which is this angle. What would be the value of that angle? So what we need to do, we need to subtract 130 degrees from 360 degrees. So if we do that, we will get what? 230 degrees. So in order to get to that point, we need to go 230 degrees in counterclockwise direction, which will give us what? A positive angle. So our coterminal angle for 130 degree, which is less than 360 degree and positive, is 230 degrees. Right? This is one way that we can use to find the coterminal angle for negative 130 degrees. So basically we use an approach where we subtracted the negative angle from 360 degrees to complete the cycle, and then we did go to counterclockwise direction to meet the same terminal point. So this angle is 230 degrees and this angle is negative 130 degrees, and both the two angles have same initial and terminal sides. Now let's consider a part B. Our part B is angle is 17 pi over 6. What does that mean? That simply means that we need to separate that in terms of 2 pi. So what I can do, I can think of separating this one as what? 12 pi plus 5 pi over 6, right? So 12 over 6 pi plus 5 pi over 6, right? So 12 pi over 6 is what? 12 over 6 is 2 pi plus 5 pi over 6. So this is my angle 17 pi over 6. Now you can see if I rewrite this, I can write as 5 pi over 6 plus 2 pi. So, as we can see, without even graphing, we can say that a coterminal angle for 17 over 6 pi is what? 5 pi over 6. Why? Because we already wrote 17 pi over 6 in terms of what? Theta plus 2 pi times n, right? So we don't need to graph this angle. But let's graph it just to see what happens. So this is my x-axis and this is my y-axis, right? Now I need to go one cycle or one rotation, which is what? 2 pi counterclockwise. So let's go 2 pi, and then I need to go pi over 6, which is what? This. And this will be my angle. And this angle, the value of this angle is what? 17 pi over 6. But the value of this angle, just this angle, is what? 5 pi over 6. So the coterminal angle for 17 pi over 6 is what? 5 pi over 6. Right? So basically, we can find the question in both ways, graphically and without even graphing the angle. There are different ways to solve the same type of question. It's up to you now what way you want to solve the question. I have shown you both the graphical way to find the coterminal angle, like using the graph or graphing the angle, and this way was all the way to this point. You already saw that the coterminal angle without even graphing. So there are different ways to do that. And this is all about how to solve an example for coterminal angles.